Alright guys, this is the rest of the practice examples for 4.4. So this is the next example we had. So we're trying to find the real solutions. So we're going to add 8 to both sides. So we got 5x to the fourth equals negative 40. Divide by 5. X to the fourth equals negative 8. And then the fourth root, it's like a square root, except it's a fourth root. If it's negative, there would be no real solutions. And this says find the real solution. So this one we're going to have no real solutions. And again, that's because underneath the radical is a negative sign there. Alright, I think there are, one more example. Alright, so Amber incorrectly factored the polynomial, as shown below. Explain and correct Amber's error. Alright, so if we look and see what Amber did here. Okay, she's got 4 terms, so I'm assuming she's going to factor by grouping. So she's got 2x cubed. She rearranged these using commutative properties, so she put the negative 2x here, and she's got 3x squared over here, which is fine, and negative 3 here. So she is factoring by grouping. All she did was rearrange the middle terms, so that's fine. So this works. And then she factored the greatest common factor from the binomial here, so she pulled out a 2x and was left with x squared minus 1, so that's correct. And then she pulls a 3 out, and she's left with x squared minus 1, so that one is correct as well. Alright, then she has the same binomial, brings it down, and then she's got 2x plus 3. So here's her mistake. So right here she should have 2x plus 3. And then times x squared minus 1. So what she did was she added those together here, and that's the part that's incorrect. It should be this instead. Then she went on to factor x squared minus 1 as a difference of squares, so that is correct. So her only mistake was that one place right there. So her answer should be 2x plus 3 times x plus 1 times x minus 1. And again, you can check this. If you take these factors and you multiply them back together, you should get what you started with. This is factored form of this polynomial. And let's see, explain and correct. All right, we corrected Amber's error, and hopefully I've explained it as I went. If you have any questions, please let me know.